Okay, this is Mr. Benson. I'm going to try this again. Last time didn't really work. I'm going to go over this practice test with you guys right here. Let's get this password typed in there. So you know exactly how to solve some of these problems. Now, it's randomized, so you might not see the solutions of the problems in the same order that I see them, but they're there. And let's zoom in on this. This is way too far out. This. Here. I think 150. Yeah, that's good right there. 150 is pretty good. Okay, so I'm just going to go kind of whiz through probably solving some of these problems right here. The first one, we have 2x to the third minus 4x squared plus 24x is equal to 0. And we want to solve, so we're going to need an example. When we solve, we should get some solutions right there. How do we solve a problem like this? Well, there's two ways to do it. There's one way is to factor it, the other way is to graph it. How about this one I factor, and then later on we'll go through and do one that's kind of like that, but graphing. So the first thing I notice when I look at this is that there's a factor of 2 in each of these. So I can factor not only a 2 out, but each of these has an x I can factor out. So I can factor a 2x out. Then what do I have left here? Well, I just have an x squared there. This 14x squared just turns to minus 7x, and this 24x just turns to plus 12, because 24 divided by 2 is 12. So right now, I already got one of my solutions for my factor. This one right here tells me one of my solutions is 0. Okay, so I know I have an x is equal to 0. I have to find my other two solutions from here, so I will make my little cross thing. My negative 7 on top, my 12 right there. And with that and that, I need to figure out what times what is that. So I got 3 and 4. Both of those are negative. So I totally have it factored as 2x times x minus 3 from this one, and x plus 4 from this one. So I have a solution of x equals 0, comma 4, comma, oh sorry, this should be negative 4, right? 0, comma 3, comma 4. And that's what I'll put in there. My 0, comma 3, comma 4. 0, comma 3, comma 4. And move on to the next one right here. And here it says write the product as a polynomial in standard form. Use these suckers carrots for any exponents. Well, because I have 3 of them right now, I know that this kind of can be tricky. What I'm going to do is I'm going to figure out what this is. And once I figure out what that is, then I'm going to multiply whatever that is by that. So let's do a quick little box right here for the first two. There's our box. I got x minus 3. I got x and 4. And so this is x squared minus 3x. And I got 4x. And I got negative 12 right there. Bring it all together. I got x squared plus x. That's from this and this, the 4x and the negative 3x, minus 12. Okay, so that was these first two right here. Now I got to multiply that by this. So really I have this times x minus 2. Right there. So this is going to be a little bit bigger box. Let's make this box 2 high and then 3 long box. So I got x minus 2. I got x squared, x, and minus 12. That's for this one right here, and the x minus 2 is for that one. This right here gives me x to the third. This is minus 2x squared. Here's x squared. This is negative 2x. This is negative 12x. And here we got 24. Combining in like terms, I got my x to the third right there. This negative 2x squared and that x squared minus x minus x. Negative 2x and negative 12x and minus 14x. And then here we got 24. So let's put that in there. Hopefully I don't make any mistakes putting that in there. So I got x caret 3 minus x minus 14x plus 24. Just look it over quick one more time. Make sure you didn't make any stupid mistakes. That's pretty good. Okay, I'm going to clear the ink on this. Move on to the next two problems. Okay, dividing problem right there. Holy cow. It's good to get this one over with. Remember, the division problem has that weird setup. So we're going to make a box that's too high. Just like this. We're going to put the 3 minus 4, 3x right here, and minus 4 there. Remember, this has to be the highest degree term. This is the next highest degree term. Then we're going to take this 6x squared right there, and we are going to plug that in to this first box right here. 6x squared goes right there. So now we have to ask ourselves, so we want to try to figure out what is this right here. So we have to ask ourselves, this times this number will give us the 6x squared. So what times 3 is 6? Well, that's 2. And what times x is x squared? Well, that's just an x. So this is 2x. Now what we can do is we can take this 2x and multiply it by the negative 4 to get this box right here. So 2x times negative 4 is negative 8x. And then we get that box right there. Okay, here's the next step. Now we've got to take this negative 8x and we're going to add it to this, negative 8x plus whatever that is, and that has to give us our 17x right there. So negative 8x plus what is 17x? That turns out to be negative 9x. Okay, so now we start all over again. So now this times this gives us negative 9x. Well, then that would make this one a negative 3. Now negative 3 times negative 4 is 12. Negative 12 plus this will give us 12. Well, that would actually just be a 0. And there we go. The remainder is 0 in this situation. So the answer to this is right up here. We got 2x minus 3. I'll put that in there as our solution. So we get 2x minus 3. 2x minus 3. Okay, moving on. So here we got question 4. Give the local max and minimum of the function. Match the max or min for the y value. Okay, so first it says, what's the degree of the polynomial? Well, the degree of the polynomial is determined by whichever term has, you find the term with the highest power, and it's just that power. This does have no term with any power. This has a power of 1 right there. You just don't see it. This one has a power of 3. So the degree of this polynomial is actually a 3. So we'll choose that as our solution. Where is that? Okay, there it is, 3. But to find the max or min, you actually have to graph this one. So let's get our graphing calculator going on this one, and we'll put it in that equation. So we have x. Let's delete this sucker. Get x to the third minus 3x plus 1. And so we'll graph that, and we get that graph right there. And so it's kind of tough to tell on that graph. So let's first do a zoom and do it the standard zoom. See how that? Okay, that gives us a little bit more insight on it. Let me make sure I didn't graph anything, put anything in weird. Nope, that looks good. So now we need to kind of zoom in on these points. Now first we want to, let's find our min first. So we're going to zoom in on the bottom of that valley right there. I'll bring the cursor over to the bottom, bring it down there, push enter just to zoom in, and it looks like that's got a height of about, remember we're looking at the y value, about negative 0.96. So let's select something that's really close to that. Hopefully nothing else is really close to it. Negative 0.96, negative 1. That's like about right. Okay. And then let's go back to that. Let's go to zoom standard again. And we'll work our way up to that other point. And just to be accurate, let's zoom in on that point. And it looks like the height of that one is y is equal to 2.98. That's really close to a 3. Something, let's see if there's something like that. We got a 3.01. Guessing that's what it is. I think it's 3.01. I don't know. Let's go back to it. Just make sure, because then there's a 3 as well. That kind of worries me if there's both of those. 3.01. Let's zoom in on that one more time. Zoom in. Enter. Enter. Okay. Yeah, I guess it's a little bit. Okay. 3.01. 3. Gosh, that's tough to tell on that one. Zoom in again. 2.99. Okay, I'm going with 3. I'm going with 3 on this one. There we go. There we go. Done with that one. Moving on to the next problem right here. Let's figure out what this one is. It says classify the following graph. Let's see. And it says is linear, quadratic, cubic, fourth degree. What is it on this one? Let's take a closer look. What do we got for that? Well, here's how you classify the graphs. Linear graphs will look something like this. Quadratic will look something like this. Cubic will look something like this. Okay? Quartic. Oh, is it quintic? What's the next one? Let me look at my notes. I always forget. Is it quintic or quartic? Let's see here. No, it's cubic. No, I did cubic. Quartic is the next one. Those look kind of like this. And then there's the next one. It's the quintic. Excuse me, everyone. Quintic looks like this. Starts down and goes like this, this. Like it's going up, but it goes up in the end. Okay, so something like that. And so we're just trying to figure out which one this is. Well, this one goes up, down, and up, and that kind of looks like a cubic to me. So this must be a cubic graph right there. So let's select that one, cubic. Okay, moving on. Number 6, find all the roots of the equation using a graphing calculator. Use a comma in your answer to separate the multiple roots. No spaces. So we need to do this one. Let's use a graphing calculator to solve this one. So bring that sucker back up again. We'll go to y equals, clear that one below. We'll put x to the third plus 3x squared minus 4x minus 12. Got it. Graph that, baby. Graph it. Remember my range was all messed up, so I'm going to go to zoom, and I'm going to do that zoom standard, and there we go. Find all the roots. So we want to find, remember, the roots are where it crosses over the x-axis. So if you look at the graphing calculator, it's right here, and right there. So we need to focus in on those roots. It looks like I have one root at about 2, one root at -2, and maybe -3. But just to be certain, let's zoom in on there just to, I just want to make sure. I would hate to be wrong on this. So zoom to enter. Yeah, look at that. Going over there. That's definitely -2, and that other one's definitely -3. So I got -2, 3, and was the other one 2? I think it was. Yeah, 2. So let's put that in as our solution there. -2, comma -1. Was it -1? Gosh, I forgot. I'm getting so old. And 2. Let's look at the graph. -2. No, -3. -3, -2. Good thing. And it doesn't matter the order you put them in. What does it? Use a comma. How to separate them up from no space samples 4, 3. Yep, there we go. Okay. Order doesn't matter. Okay, we got another classify problem here. Oh, check this one out. Okay. So we need to classify this. This sucker, if we go back up to the before, this comes down, down, and up. This is a 4th degree. 1 turn, 2 turns, 3 turns. Wait, is that 1, 2, 3, and there's one more than that. I don't know how to. This is 4th degree. How do you explain that? That's crazy. 4th degree. Maybe there's a turn and a turn and a turn. That's 3 turns. How is it 4th degree? I don't know how to tell, but I know this is the 4th degree. It's just hard to explain. Maybe if there's 3 turns and it's one more than that, 4th degree. But this is the 4th degreeer. And the 4th degree was that quintic again? Let's look at my notes again. Yeah, that's it. Quintic. No, quartic. Quartic. So let's go over there. Select quartic for this quartic. If I got that one right. And we're moving on. Oh, here we got to evaluate the polynomial x equals -2. So here, this is where you guys are going to make a big mistake on this one. You're going to forget to use these parentheses. So don't do that. Okay, so I'm going to put, what it really is saying is, evaluate for this -2. So take this -2, put it in there. Put it in right there. Put it in right there. It's also saying you better put parentheses around this -2 or else. So let's do that. So we got parenthesis -2 to the 3rd power minus 4 parenthesis -2 squared plus -2 and minus 10. And then just look at it one more time. Did you forget something? You want to make sure. And I'm looking at it, -4, it's -2, just double checking. We're adding -2. Okay, we're good to go. And I got -36 as my answer. I'll put that in there. -36. Moving on. Okay, this next one says, factor the polynomial. If you have a negative factor, then write the binomial using subtraction. Negative factor. Oh, so instead of x minus 9 instead of this, so don't put that thing in there like that. Okay, I get it. I get it. So let's do this problem right here. We need to first, we're going to factor it. We're not solving. We're factoring. So there's no There's no number like this. None of that's going on. That's not what it's asking for. It's asking for like factors, like something like this and this and this. Okay. So the first thing I notice when I look at this is each of these has an x in there. Because each has an x in it, it's fair for me to take a one way from each one of those. So I'm going to change this to be x times x squared plus 8x plus 15. Okay. So now I have this x squared plus 8x plus 15. I already factored that x out, so I know that's going to be part of my solution. Okay, I just got to figure out what's my other 2 right here. So I'm going to figure out how to factor this. I'll make my little x thing, put my 15 there, put my 8 up there. What times what is 15? That adds together to be 8. Well, that's 3 and 5. So I have x plus 3, x plus 5 right there. Let's type that in behind all that writing. So I got x times x plus 3, x plus 5. And I'll just erase this so you guys can see that a little bit better. That's how I put it in there. Good thing I erased it. Holy cow, I made a mistake. Let's do plus 3 plus 5. There we go. Okay, moving on to the next one. Number 10. Which of the following represents the interval of decrease for this polynomial? Well, shoot, I don't know. But I bet if I graphed it, I could figure it out. So let's go and do that. So I'm going to graph this. X to the 3rd power plus 5x squared minus 2x plus 1. Did I type it right? X squared plus 5x squared x to the 3rd power minus 2x plus 1. Yeah, that's good to go. Graphing it. Okay, well, let's change this. Let's change my window. I want to go up a little bit higher. Now my window, the y max right there, the y height is 10. Let's make it 30. Let's graph that. No, I meant 30, not 3. Everyone, make it 30. Let's do that. No, not 3 point. There we go. Okay, graph that. Yeah, that's a little bit better. So we want to find the interval of decrease, right? So this is when it's going down. Well, this green right here, see how this green, this what I'm writing on the graph right here, that's going up, and this area is going up, but it's this red area that's when it's going down. And it wants to find the interval when it's going down. Well, that's this part of the x-axis is when it's going down right there. And really what's happening is from the max here to the min right here is when it's decreasing. This is your min, and there's your max. So we just need to figure out what's that x interval, and the best way to do that is to zoom in on these maxes and mins. But maybe we can kind of use common sense and look at it. If we judge this as this is like 1 right there, and that's 2, and that's 3, and this is 4, it looks like it starts decreasing at negative 3.5, and it looks like it stops decreasing very close to 0. So is there anything over here that's really close to that? Well, yeah, look at this one, negative 3.5 to a little bit above 0. So we want to just put a check right there. We got the right answer. Oh, that wasn't too bad. Okay, didn't have to zoom in on that one because of those 2 infinities. That's nice. Okay, let's move on to number 11. It says correctly classify each polynomial by degree and by the number of terms. Okay, let's take a look at this first one. The first one's a 3rd degree, that's cubic, and there's 2 terms, so that's a cubic binomial right there. The next one has the biggest degree is this 2 right here, so that's quadratic, and there's 1, 2, 3 terms, and you can't combine anything, right? There's no like terms to combine, so that is a quadratic trinomial. And here, this one has 1, 2, 3, 4 terms, nothing to combine. So that's 4 terms. Once you get past 3 terms, that's a polynomial. And this is 3, so it's a cubic right there. The degree is a 3rd, so that's the biggest one. So that's a cubic polynomial. And finally, we got 3x squared plus 8. That's binomial because there's 2 terms there and there. So 3x squared plus 8, and this is a square right in there. So that is a quadratic because it's squared, and binomial, quadratic binomial. There we go. Moving on, next one. Oh, factor the following expressions completely. Okay, remember these. You gotta just kind of remember that these are perfect cubes right here, here and here. These 2 problems here. So the key thing is to get it to look like this one's going to be a to the 3rd plus b to the 3rd. We want to make it look like that. Well, this a right here, I mean that's almost set up for that's already x to the 3rd. So we know that our a is equal to x, but we got to get this to be something to the 3rd power, and 125 is actually 5 to the 3rd power, so our b is equal to 5. Now that we know these two things, we just got to plug it into that one equation. And here's what the equation is. It's a plus b times a squared minus ab plus b squared. That's for when it's addition. Okay? So we're just going to take this x and plug it in for every a, and this b, or 5, plug it in for every b right there. So when all is said and done, I should have x plus 5, and then I should have x squared minus 5x plus, what's 5 squared? Well, that's 25. So that should be my solution right there. Hopefully I'm pretty sure those are the equations. Maybe I should check my notes. Let's see. So I have parentheses x plus 5, and then x squared minus 5x plus 25. There we go. And the same for this one right down here. We got to make these perfect squares where I know my a is already x. So I got to figure out what my b is. Well, 3 to the third power is 27. So I have x to the third plus, or minus, sorry, that's minus 3 to the third. So my b is equal to 3. Now this formula is a little bit different. This is a to the third minus b to the third formula. So this is equal to a minus b times a squared plus. That's a little bit different this time. This was plus. Now we have ab plus b squared right there. Okay, so let's write this. We've got x minus 3, and then we got x squared plus 3x plus 9, because 3 squared is 9. That's what we need to plug in for that one. So we got x minus 3, we got x squared plus 3x plus 9, parentheses, and we're moving on, because keep rolling, right? On number 14, it says find the difference in we're just subtracting these. Okay, we can do this. Find the difference as a polynomial in the standard form. So remember, biggest, smallest. Remember, I hate subtracting. I always like to make addition, but when I do that, I got to change every sign in the next polynomial, or sorry, the next parentheses. So this is going to be a negative, that's going to be positive, and that's going to be a negative right there. Now I can do like terms. So let's start off with this x to the third. That's kind of like this, negative 2x to the third. That gets me a positive and a negative, so that's negative x to the third. That's what that makes right there. Then I got this negative 5 plus negative 7. Well, that's just negative 12 right there. Finally, have this positive x plus another positive x, and that's just plus 2x. But remember, I got to put this in standard form, so this has to go right there. And oh, that was supposed to go along with it. This 2x has to go right there, just like that. So that's the right way of doing this. So my final solution should be negative x to the third plus 2x minus 12. There you go. Moving on down to this next one. Problem 15. Which of the following represents the intervals of increase for this? Okay, we're back to the intervals of increase, and you know what we're doing with this. Got to graph it. Got to do it. You have to. So we go back to graphing. Here we're graphing this. Let's delete all this stuff that was on here. Sorry about that, everyone. Now we're going to put this in there. We got negative x to the fourth. Oh, this is a fourth degree polynomial plus 3x to the third minus 3x minus 3. Negative x to the fourth plus 3x to the third minus 3x minus 3. Okay, look good. Let's graph it. Oh, it's way down there. Okay, we want to zoom in on that area. Find these intervals of increase and decrease, or we're just looking at increase, right? Zoom in. So zoom in, go to the area you want to zoom in on, bring that cursor down there, push enter. Okay, so here's a better view of it. Notice here I'm increasing until I get to the top there. At this point also I'm increasing until I get to the top there. Those are the 2 points that we're really concerned about finding, not the decrease. And if you actually work your way up here, these lines, these are the intervals of increase. Right there. Right there and there. So it looks like one interval is from negative infinity to about, I don't know, what does that look like? A little bit less than negative 1. Is there anything over here that looks like that? Negative infinity to like, well, yeah, this one, negative infinity to negative 0.52. That looks like a good one right there for increase. And then we have this other one right here. That looks like it's about 1 to 2, 3, 1 to, what is it? I'm looking at this wrong. 0.69. Is that really 0.69? I can't really tell. I guess I wrote over it so I can't tell. Oh yeah, I guess that would be 0.69. Yeah, that's the 0.69 right there. 0.69 to 2. Oh, there we go. Right there. So those are our two solutions for our intervals of increase. That's when the graph is going up. So let's delete that. Leave that there. And that. Got them. Okay, moving on. Number 16. Oh, we're adding this one. Put it in standard form. So let's chunk these suckers together. The 17x squared and another 17x squared. That gives me 34x squared. And then let's go then. Oh, we got an x to the third way over here that we're adding. Is there any other x to the thirds? Nope. So we'll just put that in front here. So we have x to the third plus 34x squared. And then we have these constants. We have the -8 right here, and we got the 10 right there. -8 and 10, that's positive 2. So we got x to the third plus 34x squared plus 2. X to the third plus 34x squared plus 2. Hopefully I put that one in right. Okay. I think I did. Yeah, that looks good. Moving on to question 17. Describe the end behavior of this polynomial. So remember, when you're describing the end behavior, there's two options to go about. You could graph it, and from the graph determine what the end behavior is, or you can know something about a little shortcut. Remember, the shortcut is to look at the term with the biggest degree, because this is the term that determines the end behavior. Right there. See how it's 2x to the third power? Well, because this is a positive 2 and this is x to the third, this function is going to look like this. Something like that. Okay? So, and the function looks like this. You want to figure out what's going on as this goes to the left. As this goes to the left, it's falling. See how it's falling right there? So, falls on the left. This could be an option right here. Rises on the left. That's not an option. Both ends falls. We'll see. That could possibly be it. Both ends rise. Well, we know that's not it right there. So, between B and D. Okay, now what's going to happen to this as you go to the right? As you go to the right, this thing's going up. So, it rises as you go to the right. So thus it's not falling on both ends, so it falls to the left and rises on the right. So we got B as a solution right there. Let's plug that sucker in. So I delete this. Delete. There we go. Moving on down. I think we're almost done. Here's the last one. Oh, thank God, right? Okay, so we got a factor polynomial. If you have a negative factor on the right, okay, this is kind of like before. We're just factoring this. So you have x to the third minus x squared minus 30. First, like I said, I can notice I can take out an x out of this. So let's take that x out, put that right here. If I take that out, what I'm left with, I'll put it right here too, we got an x squared minus x minus 30. Okay. So now what I need to do is, actually let's erase this. I need to figure out what times what is negative 30. Add together would be negative 1 from this negative 1 and that negative 30. Well, this turns out to be, I think it's 6 and 5. And if this 6 is negative, we got it. So don't forget about this x initially. As a factor, we have our x, and we have x plus 5, that's from this, and we have x minus 6, that's from this. Okay, so let's put that in there. So we have x times x plus 5, and we got x minus 6. Okay, moment of truth, everyone. Let's click next, see how Mr. Benson did. Not complete. What does that mean, saying not complete? Oh, submit and finish. That doesn't make any sense to me. Once you submit, you will no longer be able to change your answers for this attempt. Yeah, I get it. How did I do? 94? What? What did I do wrong? Okay, so okay, that one's good. This is good. Which ones did I get wrong? Oh, just number 2. What mistake did I make on it? Let's see. We got x to the third. This is the multiplying one. Did I do something really weird? Oh! Did I really? Look at that. Is that supposed to be squared? I bet it was supposed to be squared. I forgot to put the square in there. Okay, so x to the third minus x minus 14x. X to the third minus x squared minus 14x plus 24. I'll make sure I put that in there. I'll double check that. But let's take a quick look at this. We got x minus 3x plus 4. So I have x squared minus x minus 12. That's for this one right here. I know I'm just doing it in my head really quick. That's really bad. I shouldn't do that. You're right. So I got x minus 2 there. So this gives me, this is x to the third, right? This is x squared minus negative 2x squared, and this gives us negative x squared. So that should be negative 3x squared. Did I do this right? Yeah, so negative 3x squared. Oh man, minus 3x squared. So maybe I forgot the negative 3 there. And then I have this 12 by that x, so that's negative 12x. And I got this and that, which gives negative 2x, which is negative 14x. So that's that one right there. And then the negative 12 times the 2 is 24. So yeah, I guess I forgot the negative 3 here, right in that spot. So that should have been a negative 3 in front of that x, and it should have been squared as well. Whoopsies. We all make mistakes, right? So that is how you do all the problems that are going to be on this upcoming test. Use this wisely. Make sure you understand what you're doing here. Benson out.